Hello to Fort Hamilton High School. This is Josh, and I present the SAT, studying for the SAT Mathematics section provided by Chang Learning for your Thursday night series. Tonight, we had lecture number 6, March 31st, 2022. And due to an internet outage at my apartment, I was unable to complete the lecture at about 8 o'clock. The last 30 minutes were eliminated because my internet went down. So I present to you this video instead. It'll be a full presentation from start to finish on the SAT. If you're watching this, I hope you enjoy it, and then it helps you with tips and tricks as you get ready for your SAT exam. So here we go. As discussed tonight, this is lecture number 6 in a series of Title I presentations by Fort Hamilton High School and Mrs. Lillian Scheck and the Parent-Teacher Association of Fort Hamilton. The SAT Math section is in 2 sections on the SAT. Section 3 is 25 minutes and 20 questions, and Section 4 is 55 minutes and 38 questions. The exam focuses on about a third algebra, also geometry, coordinate planes, charts and graphs, probability and statistics, and a few other math topics. As you can see here, tonight I had presented to you, was scheduled to present SAT lesson number 8 in our series on graphing linear and quadratic functions. Of the 58 questions, the majority of the questions are related to linear and quadratic relationships. And so to have mastery of that ensures a good score on the SAT. This is just one lesson of a 28-lesson course offered at Chang Learning. As you get ready for the SAT, I do recommend that you use preparation tutoring books, such as offered here at Fort Hamilton. You can see here in this photo from Fort Hamilton that they do have prep books for the SAT and PSAT, as well as for the Regents exams, which are another metric that we have here in New York for students grades 9 to 12. Also, prep books for if you're taking advanced placement courses are also very important for the progressing student. So I do recommend, however, that if you do enroll with an online course with an extra tutor, he or she often has a lot of test-taking strategies, shortcuts that are also a part of the lesson that can then be layered into the lessons so that you know that you're getting a modular class of say 20 to 30 lessons, but each lesson targeting questions that are going to be on the SAT. So you're 100% covered with the question types when you sit down and take the actual exam of the Scholastic Achievement Test. The other thing that I mentioned that was rather important was that there is a practical beginner strategy for the SAT math sections. Being a standardized test that nearly 2 million students take each year, it is organized with easy, mid, and challenge level problems. So for example, with section 3, if you do the easy and mid-level questions that are levels 1, 2, and 3, and then jump to the grid-ins and do the low-level questions, you've now locked down at least 10 to 13 questions and then can go to the challenge level questions. Similarly, for section 4, the easy and mid-level questions are questions 1 to 20, and then go to the grid-ins, do any questions that are easy for you, and then go to the challenge level questions. With this strategy in mind, and keep in mind I've been tutoring for the SAT for over 15 years, most students can boost their scores immediately to between the 500 and 600 point range. It's also a very good strategy because it reduces test anxiety. You're really going in with a focused plan to get those easy and mid-level questions done first, and then spending the remainder of your time with each section on the challenge level questions. In addition to this, we start each lesson of the 28 lessons with a sample quiz, which has 5 questions, 2 easy level, 2 mid-level, and 1 challenge level question for the SAT exam. So as you can see here, if you would like to pause this video, I have sent the files to Lillian Scheck, and if you've received the Google form, you can now take a stopwatch and try for 10 minutes, 5 practice questions. So if you'd like to pause the video now, I'll put up a Blackboard card for this sample quiz. And your activity to do now will be to do SAT quiz number 6, which is 5 questions and 10 minutes total time. So good luck on SAT quiz number 6. And if you would pause this video here at this point, you will then have 10 minutes to work on the quiz. And when you've completed the quiz and submitted your answers, you can unpause the video and continue with the review of these 5 questions. Good luck on SAT quiz number 6. If you're unpausing the video now and continuing with tonight's lecture, you've completed SAT quiz number 6 and submitted your answers to all 5 questions on the Google form provided to you by Fort Hamilton High School. I'll now continue with the lecture that we have here by reviewing the 5 questions on tonight's quiz. Question 1. Anna buys bananas for her Banner banana bread that she sells at a local bistro. Bananas cost 59 cents per pound, and she needs 2 pounds of bananas per loaf of bread. Every day she makes 8 loaves of bread. How much is Anna bananas cost to make 5 days of banana bread? Well, to answer this question, if she has 8 loaves at 2 pounds each, that's 16 pounds of bananas that she needs for 1 day of bread. But she works for 5 days at the bistro, so 5 days times 16 pounds is 80 pounds of bananas. She buys that at the store. 80 times 0.59 is equivalent to, here I'm just rewriting 59 cents, rounding it up to 60 cents, but subtracting 1 cent at the same time. So by distribution, it's easier for me to do 8 times 6 is $48. Which makes sense because if it was 50 cents, well, half of 80 is $40, so it has to be more than $40. So I know that I have the decimal in the correct place. Then subtract 80 times 1 cent, or 80 cents, and you get the exact answer, $47.20. A was correct. For question 2, we have a square lot has an area of 30 square meters. What's the best estimate for the perimeter of the lot? Well, for question number 2, you can actually draw a square with area 30, then each side will be the square root of 30. So the perimeter will be 4 square roots of 30. The square root of 30 is approximated as 5.477, which I rounded to 5.48. Then 4 times 5.48 would be a perimeter of 21.92, and the correct answer is B. For question number 3, we have a cruise ship uses 3.29 times 10 to the 2 gallons of fuel to go from port A to port B. Then to get to port C, it uses 7.14 times 10 to the 2 more gallons of fuel. How many gallons total were used by the ship for the 2 trips? Express your answer in scientific notation. Well, when doing problems in scientific notation, sometimes it's a good idea to convert each measurement into standard notation. So for example, if we have 3.29 times 10 squared, that's 329 gallons of fuel from port A to port B. From port B to port C, that's 7.14 times 10 to the 2, or 714 gallons. So then we'll add those amounts in standard form, and that's 1,043 gallons total. Then take that measurement and pack it up into scientific notation. So since the decimal is now here at the end of the 3, we now have to move the decimal 3 places to the left, so it's in scientific notation. 1.043 times 10 to the 3rd power, so we're now in the thousands. So the correct answer was C, 1.043 times 10 cubed. Question number 4. 3 consecutive even numbers add up to 78. What is 3 times the largest of the 3 numbers? The word consecutive means in a row. For example, 2, 4, 6, and 8 are 4 consecutive even numbers. For this example, we'll let x equal the first integer, and since they're even, they skip by 2's. So the second integer will be x plus 2, and the third integer will be x plus 4. Then we can set up the equation for the sum. X plus 2 plus x plus 4 is 78 total. Grouping like terms, we have 3x plus 6 equals 78. Subtract 6 from both sides, divide by 3, and x equals 24. So 24 is the first number in the set, the second number is 26, and the third number is 28. Then 3 times 28 equals 84. So we have the correct sum. We have the correct largest number, and that extra step means that 3 times the largest number is D, 84. For question number 5, glow art comes in 5 colors: rosy red, marine blue, army green, clementine orange, and proud purple. If you can only pick 2 colors for an art project, how many unique color combinations are there? Well, one way of solving this is to use combinatorics. And for the first pick, we have 5 color choices. For our second pick, since we're picking a second color, we're picking from 1 less. So for example, if we pick red for the first color, for the second pick, we have to pick one of the other 4 colors listed. You multiply the picks together, and you get 20 different combinations. For example, red blue, red green, red orange, or red purple would be 4 of those 20 combinations. Since we want the unique combinations, we only want the combinations not to be double counted. So for example, picking red first and then blue is the same combination as picking blue first and then red. So since there are 2 choices, we have to divide by 2 here, 2 factorial, which is just 2. And 20 divided by 2 means there are 10 unique combinations. As a follow-up, some students solve this with the sample space. So for example, we can take the red color and pair it with the other colors. So if we have red, then we can we can't choose red because we already chose red. So it would have to be red blue, red green, red orange, or red purple. Then, since those are all the combinations with red, we then, if we have a list of all of them, red, blue, green, orange, purple, we've now done all of the combinations with red. So then for the next color, we'd start with blue and go to the right. So the colors would be blue green, blue orange, or blue purple. We already have done red blue, which is the same as blue red. So just make sure that you don't rewrite it again because it's already on, we've already taken care of that combination. Red blue would be the same as blue red, so just look to the right. Similarly, we can, now that we've taken care of blue, we can go to green. Well, what colors can we combine with green? So we can do green orange or green purple, right? Because we've already done green red and green blue here and here. So we don't want to write those other colors on the list. And lastly, since we've now taken care of green, we just have orange, but orange already been combined with red, blue, and green. So the last combination is orange purple. And those are the 10 unique combinations. Okay, so also if you work with sample spacing, just do it systematically like this, just going to the right, checking off each color as you do all of the combinations, and you won't have the repeats when you generate the list this way. What we're going to do next is we're going to go to lesson number 8 and look at how some strategies with graphing linear and quadratic formulas. I'm going to pause the video now so that I can set up the Texas Instruments calculator, and then we'll work here with lesson 8 and linear equations. Okay, for the next part of this presentation, I'd like to share with you some slides along with the TI SmartView CE for the TI-84 Plus family graphing calculator. We're going to focus today on graphing linear and quadratic formulas using this calculator. And if you go to this next slide, you can see the first page of lesson number 8. This lesson and the model problems, as well as the 13 question set, were given to Fort Hamilton High School for you to practice and enjoy a sampling of 13 questions from this lesson in your preparation for the SAT. On this first page, we focus on the two most common ways that lines are presented on the exam. The first way of graphing linear equations is that we're taught slope-intercept form, y equals mx plus b. The second most common equation type on the SAT is standard form, ax plus by equals c. For linear equations, we know that the SAT mathematics sessions will contain several graphing problems. Most of the questions are with functions, which are also either linear or quadratic of the 58 questions. A few other functions are also tested, such as cubic functions, square roots, exponential functions, logarithms, exponential growth and decay, and some other investing formulas. This lesson will focus on the graphing problems related to functions with linear and quadratic equations. So what we have here is the first example, and the equation shown is y equals 3x plus 1. And as you can see in the slide on the left side, the slope is 3 and the y-intercept is 1 for this form of the equation. This is the equation, this is the type of expressing linear equations that's used by graphing calculators, such as the TI-84 Plus. So what I've done is I've turned the calculator on, clicked the button y equals, and you can see I've typed in the equation 3x plus 1 into the first blue line. What that will do is, when I click the graph button, and we'll graph a local picture here. If I check the window settings, it's a 10 by 10 graph of the equation y equals 3x plus 1. If we check the table settings and make sure that the table is starting at 0, has increment steps of 1, and click second graph, it'll give us a scroll table that we can scroll all the integer values of x and the output values of y. So for example, we can see the y-intercept when x equals 0 is 1, because b is 1. Well, what if we wanted to find the x-intercept for this equation? Well, one thing we can do is we can click second trace, and that brings us to a set of commands here in the submenu. Go down to when the equation is 0, because we want to find a root, and hit enter. And what we'll do is we want to trap that 0. So I'm moving this butterfly drone to the left of the, making sure that it's negative. I click a post, so it puts a post, like a lamp post or street lamp there, a post. And then make sure that also the y values are positive when you click the right bound. So now the 0, since I went from negative to positive with the y values, is trapped somewhere in between because it's a continuous line. Click enter once again, and it says that the 0 is at exactly negative 1/3 for this graph. But if I go back to the table, you can see that, well, the graph is set so that it's on increments of an integer. So you can go second table setting, and instead of having the table change be 1 unit, you can change that to 1/3. And make sure the starting value is, we can make the starting value 1. So then we'll still get all the integers, but we should also get steps of 1/3. And sure enough, if you look at the graph here, back at the table, that it's 1, 1 and 1/3, 1 and 2/3, 2, 2 and 2/3, 2 and 3, 3 and 1/3, 3 and 2/3, 4, etc. So now the input values are skipping by 1/3. And because the slope is 3, that means that the y values will change by 1 unit. So we have here the x-intercept as well on the table now. It confirms that negative 0.33333 and 0. Okay. The other thing that you can do that's very interesting is you can enter equations as well in fraction form. So this is interesting here if I go to the next equation, 3x plus 2y equals 6. Now, this equation is in standard form, and as you can see from Algebra 1 class, an intercept table is drawn here. So if we choose to make the first variable x 0, then this equation, this term will be 0, 3 times 0 is 0. We get 2y equals 6, so y is 3. So that gives us this point here on the graph, 0, 3. If we take the other variable, which is y, and we set y equal to 0, then this term here, 2y, will be a 0, because 2 times 0 is 0. Then we have 3x equals 6, divide by 3, and x equals 2. So we get the other intercept point, x is 2, y is 0. So when you're working in standard form, you can then solve for the zeros here, and then you have 2 points to determine a line. You can connect the dots, and there's the graph of this equation in standard form. That's the traditional way, is to use an x and y intercept table. Those 2 points can slide to the left and right and up and down, respectively, along the x and y axis, and any 2 anchor points will also determine a unique line. However, what we need to do for the graphing calculator is isolate the variable. So we need to take the equation as written, so I'll write it on the left, 3x plus 2y equals 6. But we need to write it as a y equals equation. So subtracting from both sides, we get 2y equals 6 minus 3x. And then dividing by 2 on both sides, we'll have that y equals 6 minus 3x over 2. Because the 2's will cancel when we isolate for y. So now we have 1y equals 6 minus 3x over 2. Well, going to the graphing calculator, what you can see is, let's say I click math and then fraction and hit enter. What I can do now is I can just write it here, not in slope-intercept form, but just from the isolation steps that I did, and it will give me the graph properly here in red. But since I also know that I know how to divide by 2 and write an equation in slope-intercept form, this is equal to 3 minus 1.5x. And then if I'm coding it in the calculator and I want it to look like the blue line, I would put the variable term first. So then I would have negative 1.5x plus 3. So what you're going to see now is the red line and the blue line graphed, here, but then the red line, the black line will go right on top of the red line because they're mathematically the same. 6 divided by 2 is 3, and that's negative 3/2 in decimal. All right, so when I click the graph, you'll see the original line from the blue line, and you see this new red line, and then it'll be covered by a collinear line. And there it is. So why did I do this? Why is this important? Well, the point is that if I go to the table settings here, since I put the equation in fraction form, when I make sure the table's skipping by 1/3, because that's what we wanted for the other one. Now what I'll do is I'll do second table, and you'll see the equations are here in decimal. Hold on just a second. But if I do second table set, and I clear this out. No, I want to write it as a fraction. Clear this out, and I write it as math fraction 1 divided by 6. Nope, it's still giving me the answers in decimal form. Oh, maybe that's because I have it in A plus BI form. How did I flip the mode? Can I switch it back into real? And just go to the mode. And is there a fraction type? Answers are auto or in decimal. Fraction type is numerator over denominator. It's in degree mode. Float, it's in normal. No, I think all the settings are correct. So when I go to the table, you can see now that I have it in 6, that I get good evenly spaced points because the slopes are 3 and 2. So I want those half steps in the equation as well as I want the third steps from the 3x plus 1. So there's a couple of interesting tricks in order to graph equations. You have to put it into slope-intercept form, but that might be faster just to use the fraction bar when you isolate for y from standard form. So graphing linear equations and the related word problems can be handled like that with the graphing calculator. For quadratic equations, we have, again, 2 forms that are dominant on the SAT. The first one is y equals ax squared plus bx plus c, standard ABC form. And the second is vertex form, where the square is completed, and it's y equals x minus h squared plus k. So looking at a few examples, when plotting quadratic equations, knowing the location of the vertex and if the parabola opens up or down is obviously paramount. Well, one technique for graphing these forms is to use the 7-point parabola. We'll plot the vertex point, then 3 points before it and 3 points after the vertex equally spaced. The natural symmetry of this curve will reveal the 3 points that are mapped on the same dependent values to the points after. So for this 7-point parabola here, what we'll do is, again, I'm going to y equals, and I'll clear these out. And I'll enter the equation negative x squared minus 2x plus 3. Okay, now according to the rule, x equals, for the axis of symmetry, which we learned from the quadratic formula last week, x is located at negative b over 2a. So that will be a 2 over negative 2, which is negative 1. So we know that the x value will be negative 1 where the vertex is. So what you can do when you go to the calculator is you want 3 points that are on the left side of less than negative 1 and 3 integers which are greater than negative 1. So in order to program this correctly, the 7-point parabola, what I can do is I can do second table setting, and this time starting at 0, because we're going to use the integers, because it happens to, the vertex happens to lie on negative 1. Excuse me, hold on just a second. We're going to change the table settings to integers, but we're going to enter it as ask. So when you go to the table, you see the left column is blank. It's not a scroll that you scroll up and down. So I'll enter the values from negative 4, negative 3, negative 2, negative 1 is the vertex, and then 3 points after that, 0, 1, and 2. And what we can see here is that the symmetry of the parabola makes the 3 points that are before the vertex have the same y values as the 3 points after, negative 5, 0, 3, and then 3, 0, negative 5, which gives us this local graph here. So this is known as the 7-point parabola. You first make sure that you know the exact location of the x value of the vertex. The computer will tell you the y value. So that tells us that the turning point for the parabola is at negative 1, 4 in quadrant 2. However, when we go to the graphing calculator, there it is on the graphing calculator, and hit graph, it shows it right here with the vertex in quadrant 2. So you can see that either by computing it with negative b over 2a, or you can do second calculator, and we want the maximum because this is a downward parabola. Hit enter, and again, it's the same idea of moving the butterfly drone to the left of the maximum, which is this peak here, and then to the right of the maximum, which would be over on this side, hit enter, and it will enter again and tell you the maximum is at negative 0.99999, which means is at -1. That's the way calculators work. You would round it to a -1, 4. That's confirmed here on the table here that that is the true vertex of the parabola. So this is very useful using the 7-point method to keep these values in order when you're graphing quadratic equations. Although most SAT questions are commonly in standard form, in the past few years, there's been an increase in the presence of vertex form for a parabola. So you should also be familiar with the fact that any equation can also be written in vertex form. So what I'm going to do is I'm going to take the example that we just did instead of the example in the core lesson here. And since we already know the vertex, we'll use the general form for the equation that we just did. Okay, so we know that we had y equals -x squared minus 2x plus 3. And what we're going to do is we're going to rewrite it as a completed square. We already know from our work with the in the last graphing lesson that the vertex is at -1, 4. So that's our HK. But to confirm that mathematically, we would do what's called completing the square method. Okay, so to complete this square, we'll factor out -1, and we'll write this as x squared plus 2x plus some mystery amount plus 3. And then to keep balance on the right side, we'll then subtract that same amount. Okay, this is the method of the proper method for completing the square. So to complete the square, if you remember from class, you take half of the middle term and square it. So a half of 2 of that coefficient is a 1, a equals 1, b equals 2. So we're taking half of 2 and squaring it. Well, half of 2 is 1, and that number squared is 1. So that means we have to add 1 unit here to complete this square, which we then can put in factored form. X squared plus 2x plus 1 will be rewritten as x plus 1 squared. However, since we add 1 unit to this term, it was actually -1 times 1. So that means we really put on the right side a -1. So we have to take that same amount, -1, and subtract it to keep balance. So be careful with the signs when you're doing this. So since we added 1, well, we multiply that by -1 when we distribute here. That means we really added -1 to the right side. So we have to subtract the same amount. And that will make it 3 plus 1 or plus 4 when we combine like terms. So now we have the same equation written in vertex form. Y equals -1 times x plus 1 squared plus 4, which tells us that the vertex is at -1, 4. So I'm going to put that down here as the red line. This is the identical equation, but it's written in vertex form. Okay, we just use this method called completing the square. So negative parentheses x plus 1 squared plus 4. Hit graph, and you can see the red line is collinear. It's right on top of the blue line. If you're not convinced, you can go to the table of local values, and you see that all the points are mapped perfectly For the blue equation and the red equation, we go to the graph, they are collinear. Okay, so they are the same equation. First one is in standard form and the equivalent equation in vertex form. On the SAT, knowing how to graph in standard and also in vertex form is very important to switch from one to the other. To go in the other direction, remember that you would use FOIL to FOIL out the equation and then rewrite it into standard form. What we're going to do now is I present to you for the next section 13 questions specifically designed as a sample set for Fort Hamilton High School of SAT lesson number 8. So on this lesson, you'll find easy, mid, and challenge level problems for you to try on graphing linear and quadratic equations. So for this section of the presentation, I invite you to try at Fort Hamilton High School SAT Math classwork number 8, the mini set, Graphing Linear and Quadratic Functions, set C. These are designed to be 15 to 20-minute practices for schools who would like to know a little bit more about the SAT class at Chang Learning. And here you can see I have the classwork as 5 easy level and then mid and challenge level. And then it ends with 3 grid-in questions, which you can see here, easy, mid, and challenge level for the SAT preparation. What I'd like to do is, again, give you 15 minutes practice tonight for if you'd like to work on SAT lesson number 8. So please pause the video and you can explore this worksheet. Since it is 13 questions, and remember the pace is like 2 minutes per question usually, I would, if we had ample time, use 30 minutes of practice for this worksheet. So if at this point you would like to pause the video and try these 13 questions, although we usually, due to time budget, give 15 to 20 minutes to practice these and then go over a few questions, I would recommend for these 13 questions, having 30 minutes set aside to really explore the worksheet and the ideas as you get ready for graphing linear and quadratic formulas. All right, so please pause the video now to work on the 13 question sample. And then, as a final note, we'll go over the 3 grid-in questions as a class for final review. Again, please pause the video now to work on sample set for worksheet number 8, 13 practice questions. If you have continued with this video, you have completed or attempted several of the questions on SAT worksheet number 8, Fort Hamilton High School 13 question sample, with a recommended time of 30 minutes total for all the questions. What I'd like to do now is go over just 3 of the questions on the set. So if you look at the worksheet here, I'll give step-by-step solutions to questions 11, 12, and 13. All right, question 11, considered easy level, reads, in the xy plane, the line with equation 5x minus 10 crosses the x-axis at a point with coordinates a comma b with b equal to 0. What is the value of a? Well, what we have here is we don't have a picture drawn, but as a quick sketch, we know that for y equals 5x minus 10, we know that the slope is 5, positive 5, and we know that the y-intercept is negative 10. So I can certainly graph sort of a quick sketch. If that's negative 5, that's negative 10. And then since it's going up by 5 and 1 unit to the right, and then up by 5 and 1 unit to the right, and up by 5 and 1 unit to the right, I can approximate or do a quick sketch of the line here like so. But since we want the value when, we want to know the value of A when B equals 0, we want to know this point, A comma 0, which is here in the picture, which I'm drawing as ordered pair right here, A comma 0. Since Y is 0, use the formula itself. So we have Y equals 5x minus 10 means that 0 equals 5 times mystery number x minus 10. Add 10 to both sides. We have 10 equals 5x. And then for the last step, divide by 5, and 2 equals x. So the correct answer to question 11 is x equals 2. That is a linear equation. For question number 12, it says if h and k are constant and x squared plus kx plus 6 is equivalent to x minus 1 times x plus h, well, what is the value of k? Well, if we think about this for a second, you have to understand the nature of FOIL. So if we have x squared plus kx plus 6, and that's equal to, in factored form, x minus 1 times x plus h. We know from FOIL that we have first, outside, inside, last. X times x here, I'll draw it as green arrows. X times x is x squared, x times h, negative 1 times x, and negative 1 times h. But we know that the last term for x squared plus kx plus 6 is 6. So that means that 6 is the constant, which equals negative 1 times h. So we can solve for h that way. Here, I'm just highlighting it here. 6 is the constant number. Well, the constant number comes from the last in FOIL, in FOIL. The last of the first binomial and the last of the second. Dividing by negative 1, we know that h is minus 6. Okay, so we can set up the equation in factored form as x minus 1, x minus 6. Then we can now use FOIL on the factored form to find out what the middle term is for k. And if we do that, we have x minus 1 times x minus 6 equals x squared minus 6x minus 1x plus 6, which means that the equation really is x squared minus 7x plus 6. And we know that k equals 7, negative 7. For this quadratic. So I'm circling it here. We want to find k. Well, k is then negative 7, and the correct answer is negative 7. For question number 13, it says, well, how many intersections do the graphs x squared plus 10x plus 19 and y equals a half x minus 9 over 2 have in common? The fastest way to do this is to use the graphing calculator. We have a quadratic and linear system. The first equation is a quadratic, and the second equation is a straight line. So what I'll do is I'll open up the screen here, but I want to use my Texas Instruments calculator, and I'll type both equations into the graphing calculator. This can, of course, be solved algebraically if you set the equations equal to each other, and then solving with the quadratic formula. But solving it graphically is really good if this is a question a section 4 question. So we have x squared plus 10x plus 19 for the first equation. And for the second equation, again, I'm just using the fraction template. We have a half times x minus 9 halves. So the intersections are points where the graphs have in common. And lo and behold, when we do this, we can see that there are no intersections. The parabola here is completely above this sloped line with the slope of a half. And there are no intersections. There's a gap here between the vertex and the line is below it. So the correct answer was 0. So for the 3 grid-in questions, the correct answers were 2, -7, and 0. Well, I hope you enjoyed this review of the worksheet and that it's helped you with a few calculator skills. And as you get ready for the FHHS, you've enjoyed these sample problems. As a final note, I'd like to again thank the Parent-Teacher Association of Fort Hamilton High School, who invited me here today to be the guest lecturer for SAT prep. Please remember that Chang Learning Center has this course offered in the summertime as well as its ongoing course here in the spring, and offers test-taking strategies. So even if you are using standardized test prep books, we do have summer classes for grades 1 to 7, SHSAT and SAT preparation here at Chang Learning. There is an early bird discount of $150 less if you register before April 1st, and $100 discount if you register before May 1st. It's a pleasure to serve the communities here in Brooklyn as they get ready for their standardized tests. I am the math specialist for grades 7 to 12 and do class and one-on-one tutoring for grades 7 to 12 as well as college level courses. Again, my name is Joshua, and I'm honored to be here as your guest lecturer at Fort Hamilton High School. Again, thanks a lot to Lillian Scheck, to Tamara, to the translators, and team of the Parent-Teacher Coordination at Fort Hamilton High School. Good luck with your studies. Stay organized, stay confident, try again. And perhaps I'll see you again as you get ready for your next math goal on standardized tests. All right, thank you for watching this video, and good night. Thank you, bye-bye.